I'm Faraz Malik, and this is the testing section of my NEA project titled BrentwoodCompanion. This is an app that helps newcomers navigate around the school site, and it also implements the Google Suite infrastructure to allow students to find catered routes that correspond to their lesson plans. This testing video is going to cover the 6 core components of the app. The documentation's testing are replicated here in video form, and there are timestamps down below for you to jump between the sections. The first of these features is the route selector, which enables the user to intuitively select a start and destination and find a route between them. The second of these features is Google Login, which enables the user to sign in with a school Google account and have the app retrieve and store their calendar events offline inside the app. The user can opt out at any time and have the app delete their calendar events, and these events are used in the route autofill feature. The third component is the map view, which provides a visual illustration of the route the user has selected. It also provides buttons which launch a preview of the route and a street view-like experience for step-by-step guidance. The fourth of the features is the route autofill feature, which automatically selects the lessons and their locations corresponding to the departure time that the user has selected, and it enters them into the app. The fifth feature is the route preview, which launches automatically whenever a new route has been entered, and it provides a set of images corresponding to the start and destination, along with an overview of the route ahead. The final feature is the street view, and is arguably the most useful one. It allows the user to see a curated series of images that each correspond to a checkpoint along the route they have selected.
Let's begin with testing the route selector. 11 tests were carried out in the documentation for 5 major operational objectives, which will be replicated here. Number 1. Touching on either text field in the route selector shows the location selection data in the table view. Number 2. Typing onto the text field shortens the selection data in the table view correctly. Let's try Otway. Now let's try Hall with a space before and after the word. We can see the results include the locations where Hall is the middle word because of the space. Let's try Not a Location, which is obviously not a valid location entry. We can see that there are no cells in the table view, which is what we would expect for such a location. Number 3. The status boxes should update properly, which inform the user whether they are editing and whether their entry is valid or not. Let's click inside the text box, and the status box has turned yellow as the user is editing. Let's click outside the text field containing Otway, and the status box has turned red from yellow because there are 4 possible search results. Let's add in this, and now we've shortened the selection to 1. Now touching outside selects the single cell, which is the only possible result from our text entry. The status box has turned green to highlight a good selection to the user. Number 4. Touching a location cell allows us to select that location for the text field we are editing in. I have selected the first cell, which has been selected via the touch action. Number 5. The route button is only enabled when both the start and destination have valid selections. Let's try any destination here from the location selection list, and as you can see, the route button has been enabled. Number 6. Pressing the route button with a valid route selection passes the start and destination to the map view. So I'll press the button here, which has been activated from our previous test, and as you can see, the selections we have made have been passed to the map view. Let's test the Google login. 10 tests were conducted in the document for 7 objectives, which will be redone here. Number 1. Touching the signing button presents the sign-in page and works subsequently. The user can choose to sign in and authorize calendar access. The details have also been updated in the settings view for the user. Number 2. The status alert box updates appropriately with the outcome of a request. As you can see, the box is green from the previous login. Let's open the login view and close it, and the status box has been updated from yellow because the process was ongoing to red because of the error. Let's log in and not give consent, and a HTTP 403 error has been received and displayed, which is the code for forbidden. Number 3. The calendar events are stored offline. Let's see that the storage view is empty. I've just successfully logged in. Let's head over to the storage overview, where we can see that my calendar events have been successfully updated. I will now quit the app and I will relaunch it, and we can see in the storage overview that the calendar events have persisted, showing offline storage working effectively. Number 4. The opt-out button permanently deletes the user's details and their calendar events. Let's open the storage view, where we can see the calendar events are being stored. Let's opt out, and the user details in the settings view and the calendar events appear to have deleted themselves. Let's quit the app and relaunch it as before, and we can see these changes have persisted with the offline storage. Number 5. The network request only retrieves 2 weeks of calendar events and allows for the retrieval of personal calendar events. We can see here that custom event 1 has been retrieved, but not custom event 2, because we can see on the calendar that custom event 2 is more than 2 weeks from now, while custom event 1 is 2 weeks from now. Let's test the map view. Number 1. Selecting a node in the route selector creates a corresponding annotated pin in the map view. We can see that it does. Let's click it to ensure its details correspond, and we can see the text match up. And it says start because we entered it in the start text field. Number 2. Alerts a user if no route can be found. I'm going to select untraversable, which is an untraversable destination, and we can see when I click route I am presented with an error message because no route was found. Number 3. The map view automatically presents the route preview when receiving a good route. We can see that this is the case, as I have passed in a good route selection and I have been presented with a corresponding route preview. Number 4. A good route creates the correct annotated pins and an appropriate polyline to connect them. The route from test 3 is visible after collapsing the route preview, which was automatically presented. Let's inspect the pins, and we can see that the descriptions match up to the entry in the route selector. Number 5. The map view prevents the launch of the street view and the route preview when no route is found, and prevents the route autofill page when no calendar events are found. No route is currently in place. Let's try launching the route preview and we can see an error. This is also the case for the street view. Let's check the storage overview, which is empty. Let's try opening the route autofill page, which has been blocked, as expected, because no calendar events are currently being stored offline. Let's test the route autofill page. Number 1. The route autofill page is set by default to the current time. This is the case. Selecting the scheduled button makes the date picker selectable, which does happen. To conduct the next few tests, I've set the following 1-hour events, as you can see in the screenshot. Please use it as reference when needed. Number 2. The status box and event selection update as expected with the departure time. Let's start with a time set to 1 PM. We can see the warning because the start event was not found, as this time has made test 1 the destination event. Let's set the time to 5:30 PM, and we can see that the events were too far apart. It corresponds to test 3 and the event called too far apart having a 4-hour 15-minute gap between them, which exceeds the 4-hour threshold for finding a route between 2 events. Let's set the departure time to 2:30 p.m. and we can see that test 1 and test 2 have been selected correctly. Let's set the departure time to 2:41 p.m. just 11 minutes after, and we can see that test 2 and test 3 are being selected as expected because we are far enough into test 2 for it to become the start event here. Number 4. The Get Route button is only enabled when a good selection is made. Let's set the departure time to 1 p.m. and the button is disabled, 1:25 p.m. and the button is enabled, 10:15 p.m. and the button is disabled as test 4 does not have a valid location description for the app to process. Number 5. The route is passed successfully to the map view. We can see that this is the case for the 1:25 p.m. departure time. Note Allison and HADC, Hardy Amy's, as the locations. Let's press the button and we can see the street view has received this correctly. Let's test the street view. Number 1. The street view shows the images and checkpoint details in the right order, which we can see that it does, with the images being in sequence. The percentages show the details are in order because they are increasing correctly. Number 2. The memory consumption of the app remains below 150 megabytes while using this feature. The tests failed previously, as shown in the memory graph spiking to over 800 megabytes here during runtime. This is because each street image was unnecessarily being decoded entirely, as shown in the diagram, while only a fraction of it will be used on the image view display. Image sizes can rise from 3 megabyte files to 50 megabytes in memory because of the decompression. The UI image structure also uses caching, allowing a user that has seen multiple routes to push memory usage over 800 megabytes. This was solved by using a downsampler, which only decodes according to the size of the view window, preventing the storage of unused data in memory. For example, only sampling 1 every 4 pixels every 4 rows for a 5x5 window from a 20x20 image uses 94% less memory. This effect, exaggerated with 12 megapixel photos, results in the memory consumption consistently remaining below 150 megabytes even if there are more than 15 images in a single street view route. Number 3. Swiping between images remains a smooth experience. We can see this is the case, an advantage of downsampling the images while the street view loads so that they are ready to be displayed in the street view.